Hi, today we are going to take a look at this vintage bearing indicator. There is a CRT and two knobs here. One for luminosity probably, another one for something else. There is a post acceleration of 10 kilovolts. On the rear there is a circular connector. This connector is specific for this unit. There is a fan. This thing was manufactured by Marconi Avionics. You can see the NSN code. Generally, this is a simple X and Y analog monitor. At least it should be possible to display some Lissajous patterns. We can see here the shield of the CRT. The shield is made generally with new metal or permalloy or an alloy with high permeability. We can see here a board which seems to be symmetrical. We have maybe here a part of the deflection amplifiers. There is another board underneath this one. I think I will need to desolder all these wires in order to remove this board. This thing is not optimized for service for sure. Here we have 3 trim pots. I don't recognize these parts, probably op-amps, SNC S2702. Let's see the other side. Okay, so here we have the power stage of the deflection amplifiers. And here we have the EHT power supply. This is the post acceleration, 10 kilovolts, and we have other voltages here. We have a better view on the shield here, and we can see here the connection to the deflection coils, and they are effectively connected to this board. Actually, it is not a board, it's an aluminium plate. There are several standoffs for the passive parts. So effectively on that device we have only the X and Y amplifiers. We can see the second board here. It's probably the power supply board or maybe the cathode circuit for the luminosity. We can see the second board here. We can see the wires here which are connected to the CRT. We have 2 brown wires which are obviously the heater. And we have other wires, the cathode, the Venet, the focus, and the first acceleration voltage. We can see here the schematic of the video board. We can see first that the heater is connected between ground and terminal number 1. Terminal number 1 is also connected to this potentiometer, which seems to be the luminosity potentiometer. And the wiper of the potentiometer is connected to the base of this transistor, which is actually a current source. Obviously, the heater voltage should be negative relative to ground. The current flows through this resistor, which is connected to this voltage plus 40 volts through this resistor and this diode. This line is connected to the CRT. So this line seems to be the cathode of the CRT. The video input is here. It is connected to the base of this transistor. The collector is connected to this second transistor through this resistor here. This circuit is an acceleration circuit. We can see that the video signal on that line is connected to this transistor through these 2 diodes. This is actually a Baker clamp. This diode permits to have a negative feedback. So this permits to accelerate the commutation of this transistor. When Q1 is on here, there is a voltage of 0.7 volt approximately on the collector. So this permits to have a minimum charge stored on the base emitter junction of this transistor. The voltage on the collector is fed to this emitter follower circuit here, and there is an AC coupling between the emitter here and this point here. We can see also two medium power transistors in TO66, one here and a second one. We can see first that the screen is burnt in the center here. We have here a circuit board with 8 LEDs. These LEDs permit the lighting of this reticule. This complete assembly is called stop shock. We have here the schematic diagram of one deflection amplifier. For each axis there are two deflection coils, one here and the second one here. This permits to simplify the drive circuit because the current flows in one direction only. When the input voltage is positive, this amplifier is active. We can see that we have here a voltage to current converter, and when the input voltage is positive, the output here is negative, so therefore the current flowing through the second coil here is null. We can see that we have here an inverting amplifier. This trimmer permits to adjust the gain of this amplifier in order to have exactly the same absolute gain than the second amplifier here. As you can see, this thing works.